Okay, I'm dreading doing this. Cellular respiration fermentation. This is going to be painful for both of us. Equally painful. Bottom line is this. This sucks. Okay, so let's start. So this is your glucose, CH. Remember this. Remember this. This is the key. Oxygen, carbon dioxide, water. Right? You make waste. Right? Basically, you breathe it out and you piss it out. Right? That's the bottom line. You eat food, you breathe in the oxygen, and then you make piss and you breathe it out. That's respiration, right? That's the bottom line. And that's what happens, right? In life. You eat, you piss. And that's what it is. And then out you get energy and heat. Energy is ATP. And what's beautiful about this thing, the energy is stored in the ATP. This is fucking key. You're thinking the energy is released. It's not released. It's in the ATP, which then later releases it. This is the hookup. This is what hooks up this whole thing to future reactions, right? You're thinking, oh, he's lost. That's game over. But this guy is like the baton in the relay race, right? So, I mean, he's now carrying it. Remember I told you that I sent you a little message, triphosphate, right? What's the special thing about phosphates? Remember, never forget this whole thing about the phosphates. Phosphates are unbelievable. Remember, the phosphates is just, it's like a God-created item. Remember, to tell you about the phosphates, just you have to see, what a fucking phosphate. Phosphate, what's amazing about the phosphate, here, this phosphate is by itself. But a phosphate had left this. When there was a phosphate here, it shoots off. Why does it shoot off? Because it was also negative. Negative and negative repel each other. That's where it's almost like a gun. And that's why those motor proteins, they actually move. But it's almost like kind of it's like literally a burst of energy because these repel each other. So it's the movement of the ATP. It's almost, the ATP actually moves as the P goes this direction. So the P goes pew, the ATP go pew, and they separate each other because of the phosphates that are hooked up. These are negative. Then you have another P that's negative. Another is negative. Remember, at the end, there are two negative charges. See, these are negative 2. But if this was in the middle, it's a negative 1 charge. So ATP has how many? 4 negative charges, right? 4. Okay, so we're going to go out. So now, let's go to pain. Sheer pain. So we're going to go to this. This is, remember, that is the key concept, redox reaction. The whole world of biology revolves around redox. The idea is this, is that this oxygen actually is becoming reduced. It actually does look reduced, right? It's smaller, but not really. Actually, that's not what it means. It actually means that it's reduced means it's picking up the electrons. Right? Gains electrons. Reduce. You would think something is getting reduced is reducing something, but here, when you're reducing something, you're gaining something. So these guys should have come up with some better terms, but these guys are crazy. So they're dumb. It becomes reduced. Well, you think that if it's reducing something, well, you're actually gaining electrons, but the reason it's reducing, you're reducing the charge. So it becomes reduced in charge. So something becomes reduced, it gets reduced in the charge, it becomes more negative. Then this becomes more oxidized. It becomes more positive. Now, how you remember that? Basically, there's a little trick that they have a little, I think there's somebody made a rule. Oh, well, anyway, it's not here. Bottom line is this, just know that when you become more positive, you're becoming oxidized, and you're getting like, so the bottom line is this is becoming oxidized, that's becoming reduced. You're going to have to memorize this because you're going to have to then ask who's the reducing agent, who's the oxidizing agent. That's the opposite, meaning that who is the donor. He's actually giving the electron to whom? To the Y. So he's actually the donor. So he's actually the reducing agent, right? He's the one he's like, giving the electron. This guy actually is accepting the electron. The one who accepts the electron acceptor, is the oxidizing agent. He actually, so you have to think of it in 4 ways. The agent and who's getting impacted. This part you have to, it gets annoying because you got to always think about it properly. Because you fuck this up, this is where this thing will mess. You can't screw this up because they'll nail you on this. Which is the oxidizing agent, which is becoming reduced, which is the reducing agent. So you have to be very, 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 very careful. And examples per examples, you begin to recognize what's going on. Okay, so let's look at this. Let's cover our hands. Okay, test yourself. Is CH4 the reducing agent or oxidizing agent? Real quick. How about oxygen? Oxygen is the oxidizing agent, but methane is the reducing agent. Now, try to remember this. Basically, bottom line is this. The electrons, remember, oxygen loves, is the reason oxygen is in all of these in this whole thing, the whole point of oxygen, the way you remember this, it's always the electron acceptor in all reactions pretty much everywhere, except in photosynthesis. In respiration, oxygen is drives the electron transport chain. So in the end, the electron transport chain is driven because at the bottom of the electron transport chain is this guy salivating, waiting for the electron to come from the higher state, and keeps coming down and down and down and down till he finally picks it up. But he's the one who's pulling it down. So oxygen is actually pulling down the oxygen from the top, where I'll show you how the electrons at the top of the chain and just driving energy. Remember, energy is actually being created as the electron is traveling down till it finally is taken on here, and then what? Becomes the waste product, the water, right? So when it finally gets the electrons, finally waiting, what's its reward? It turns into water. It actually, that's what it is. It becomes, that's the oxidizing agent. So it's actually pulling the electrons from everybody. The reducing agent means, remember, it's got a lot to give. It's the sugar. Hey, what does sugar do? It gives you love. What's love? Electrons. So it's the reducing agent. It's the donor. Okay, so he's giving the electrons. Okay, so he gives away the electrons. Now when he becomes and gives it away, he's still not sugar anymore. He becomes something else. He becomes the carbon dioxide. Now, this is an important question, and they always ask this question. Where does the oxygen come from? The carbon dioxide, where does the oxygen come from the water? And they love this question. So the water oxygen comes from the regular oxygen. The oxygen that comes from the carbon dioxide, where did that come from? Huh? We'll talk about that. So where did the oxygen from here come? And where did the oxygen go here? And what's interesting, it's both. Has to be, right? Because there's 2 O2 here, O2 here, 2 O2, O2 here, and 2 O2 here. But just one O2, right? So that's an important thing. Okay. Let's look at this again. This is an important thing to break down. Here, though, it's different. This is different now. Where are all these molecules coming from? Here, it's 6 coming over here. But here, it's a mix. It's O from here, but O also from here, right? We have to figure this part out. I forgot this part. Where does the O from carbon dioxide come from? C obviously comes from there, but this obviously comes from the water. So we'll have to figure this part out. So we'll have to explore this. Now, this is the important part that I want you to remember. Okay.